Can you see the screen now?
Yes.
Okay, okay then. Last class we discussed about PGP, and we also discussed about what is the difference between network security and information security. Then we saw about this Radix 64. Radix 64 alone I have to teach you. Apart from that, what is segmentation and reassembly, and the other message processing functions of PGP I have already taught you. Okay, so the last thing before going into PGP, I mean SMIME, is please look at this diagram, students. A very important diagram. See, the first diagram A is transmission diagram, how transmission happens. So if there is a file X, then whether the signature is required. If it is yes, generate the signature. We will generate the signature, and after generating the signature, you will go for compression. Is that clear? Compression is basically your zip, using zip. Is that clear? Then after compressing, whether you need confidentiality, yes, if you need confidentiality, you encrypt it and then convert it into Radix 64, and then you will send. So if you look at this, the conversion, the compatibility will be at the end. Is that clear, students? Am I clear? Can you're seeing the diagram, right? Hello?
Yes, sir.
Okay. Okay. So first, what you have to understand here is, you have a file, you will check whether signature is required. If yes, you will go for creating the signature, and after creating the signature, you will compress it, and after compressing, you will do the confidentiality part. That means you will encrypt it, and then you will do the conversion. Is that clear? So basically, these are the steps which are taken, handled in the PGP. Is that clear? So if you get a question that draw the generic transmission diagram, this should be your diagram. Is that clear? So flowchart. Then what happens in the reception? I mean, after receiving, so convert from Radix 64 to your normal ASCII. So after converting it into ASCII, so it will check. It will be encrypted, right? The other way, you have to go from bottom to up. It is converted into Radix 64 format. Again, convert it back to ASCII, and then again you decrypt it. And after decrypting, the next thing is, here you are compressed. Here you have to decompress, and after decompressing, you have to check the signature, and then you will get the actual X. This X, you will get it as it is here. Is that clear? So these are the two diagrams which are very important and which you should know, because in this diagram you will clearly understand where signature is done and where compression is done. Is that clear, students? Shall we go to the next point topic? Okay, so this is about PGP operation, the summary of PGP operation. So yeah, PGP session keys, I've already told you yesterday what are session keys. Need a session key for each message. So for every transmission, you will generate a session key. I mean, only for, it's a symmetric key. For encryption and decryption, you'll be using the same key. So this is PGP message format. Again, this is also very important, students. The diagram is very important. Okay. So let me like you should draw this diagram. You may get these kind of questions. So be very careful with this diagram. So the first thing is, see, there are three components here. If you see, there are three major components. One is session key component, second one is signature component, and the last one is message component. So you have to know this. There are three components. Okay, session key components. What does the session key component do? It has the key ID of the recipient's public key used for sender to encrypt the session key and the session key itself. Is that clear, students? So you can see here in session key component what you have a key ID of recipient's public key. Who is recipient actually, students? Whom do you call as recipient?
B, sir.
Who?
Usually, if A is the sender, B is the recipient.
Yes. So basically who receives? Who receives is the recipient. Is that clear? If A and B, A is sending data to B, B is the recipient and A is the transmitter. Okay. So now this session, every message will look like this, and this will have the key ID of the recipient's public key. Then you have a session key in it, that is called as session key component. And you can see here this is not compressed. Okay, the compression part happens only for signature and message, not for this. Is that clear? Then you have a signature component here. So in that signature you have a timestamp key ID of sender public key. Is that clear? So in session key component you have recipient's public key, here you have sender's public key, and leading to octet of message digest. So leading to octet of message digest, that means you have used for message digest is MD basically, which is used for creating hash codes, and the leading two octets of that will be added here for receiver to understand in what message digest is used to basically to get the hash code. And then you have the actual message digest itself, and then finally you have the message part. In that you have the file name, timestamp, and actual data. And this complete diagram is important. Here this side you can see which part you are actually compressing, which part you are encrypting, and which part you are converting totally. Is that clear? R64 is radix 64, EKS is you are encrypting using the session key, and zip is basically you are compressing it. So this diagram is also very important, students. So please, I suggest you to write it once. So that will be better. When you practice, please write it once. Okay. Any question regarding this, students? Okay. So before I jump into mine, I would like to discuss few things, very minor things regarding mine. What is the difference between PGP and mine? So you can make this note, students. Please note it. It is not there in the slides. So the difference between PGP and MIME is, in MIME you don't have compression. Okay, MIME doesn't compress its data. Apart from that, encryption, yes, in both it is there. Authentication is there. Non-repudiation, it gives compression. PGP have compression, whereas SMIME doesn't have compression. And encoding, yes, radix 64 encoding in both PGP and MIME it supports. And there are some other differences like the key length for encryption, or which key management algorithm is used. Those things are quite different. And the other difference is basically, I think, yes, that's the major difference. And as I said you yesterday, the other major difference here is attachments. You are securing the attachments also, which PGP doesn't provide. Is that clear? So these are the differences between MIME and PGP. MIME is multi-purpose internet mail extensions. Okay. Um, so that's about MIME. And there is one more point I would like to give you, which again you have to note down that, students. How do you make PGP effective? Is that clear? There are four things which you have to keep in mind. How do you make PGP more effective? Please note down this point, very important. uh, that is not there, and I have not added that in the slides. So how do you make PGP more effective? Or you can take the heading as making PGP effective. Please take this point, making PGP effective. Am I audible, students?
Yes, sir.
Okay.
Yes, sir.
So making PGP effective, please note down. The first point is end users role in making PGP effective. End users role in making PGP effective. So how it can be done? See, we all know that no encryption algorithm provides 100% security. Is that clear? Please keep this in mind. No encryption algorithm provides 100% security, but at least you can make it difficult for a intruder to decrypt it. Is that clear? If a encrypted data is received by the intruder or an unauthorized user, the unauthorized user should face huge difficulty and huge cost, or you make it expensive to decrypt. Is that clear? That is possible. Is that clear, students? So the kind of algorithms you use in PGP will take this part. Is that clear? So that's what end users role in making PGP effective. You have to encrypt in such a way that decrypting it will become very expensive, and because of that the intermediate user or the unauthorized user will don't go for decrypting it. Is that clear? That is one thing. Second point, keeping passphrases and private keys completely secure. Very important thing. Keeping passphrases and private keys completely secure. Please make a note of this. Keeping passphrases and private keys completely secure. If you keep your passphrases or private keys easy in an easy way where the intermediate user can access it, then it is of no use again. Is that clear? Cracking the encryption will become very easy. Okay, so please make sure you keep your passphrases and keys, private keys, very safe. Next one, third one, being skeptical of public keys received. Being skeptical of public key received. Okay, that means whatever the public keys you receive, public key of other users, don't believe it as it is. Is that clear? Wait for the identity of the user, check the identity of the user, and then you proceed with encrypting or using that public keys. Or the best way is directly contacting the person and getting the public key of that person manually. Is that clear? So that will be more easier. So because when you are sending a packet from A to B and you think B is the right, whatever the public key that you have received of B is right, but it might be the public key might be a key of a intermediate user or unauthorized user. Is that clear? So you cannot simply believe the public keys whatever you have received. You should evaluate it. You have to check the ID of it. There are many processes for evaluating it. We are not going in depth towards that. What you have to understand is to be skeptical of public keys whatever you have received. Is that clear? And the last one, fourth point, is key authentication. Key authentication. The key what you have received, you have to check for its authentication. Is that clear? Like contacting the superior of any person. basically in organizations, it has to be done. Authenticate the key. Is that clear? That is what it is quite not it is not practical in many cases, but it can be considered as one of the measure to make PGP more effective. Is it clear, students, these points? The message structure of PGP, the transmission and reception, the previous slide what we discussed, this one, generic diagram of transmission and reception, how the PGP message looks, how do you make PGP more effective, what are the differences between PGP and MIME. So hope these things are clear to you now. You have any questions regarding PGP? Because we are moving into MIME now. PGP key rings I've already told you in the previous class. And this is not required. Whatever is required to you, only that I will retain in the slide and I will share it to you. Today I will do that, students. So, friends, we have discussed about the quiz on Saturday, on this Saturday, right?
Yes, sir.
Okay. So we need a change in that. When is your midsem exams?
From 30th, sir.
From 30th. Okay. So what about this Monday? Will it be fine for you having the quiz on Monday instead of Saturday? Any placement activities do you have on Monday?
Placements is there in the evening, sir. Not sure about morning. 3 companies are there.
Okay. So I will speak to the other faculties and take around 15 minutes time. Monday, like first hour, second hour, what do you have? What do you have in the first hour?
Machine learning, sir.
Second hour,
SICP.
who is handling machine learning and SICP?
Priyanka ma'am and Beena ma'am for ML and Shriba ma'am and Uma Maheshwari ma'am for SICP.
Okay. Okay. So Monday morning we will have the quiz. Okay. So I will let you know the time. But be prepared. Monday morning we will have the quiz. I will share you the PPT by today. Okay. Is it fine?
4th hour we don't have any class, sir.
Then that is better. We can have it in fourth hour itself. We need not ask anyone for their time. So okay, then fourth hour we will fix. Monday fourth hour we will have the quiz. First 15 minutes of fourth hour. Is it fine?
Yes, sir.
Okay then. I will share the slides by end of the day. I'll tell you the portions also by end of the day. Okay. I think I've already told you.
So
Portion.
first chapter you said.
First chapter only authentication. Yes.
Yes, sir.
First chapter we will have for quiz. Okay. So yes, next coming to MIME. Before going to SMIME, let me give you information about MIME. MIME is multi-purpose internet mail extensions. Say it provides some of the extensions like non-text attachments, like images, videos, audios, and other multimedia messages. Ability to send multiple objects within a single mail, single message by attaching it. So here the character set used is ASCII. Um, and then other information is the text is not limited. I mean, you can have an unlimited length of the text. So these are some of the features of MIME. So the major thing is MIME will help the email protocols to permit users to transfer any kind of images. Is that clear? Image, sound, and program and any kind of other attachments. Is that clear? Please make a note on this point. Please take this point, students. Very important point under MIME. Okay, I think that is there in the slide. No need to write down. Let me go through this. So original email, that is RFC 822, was text only, and the most recent version of is RFC 5322 internet message format. So in the RFC 5322 context, uh, messages are viewed as having an envelope and contents. RFC 5322 applies only to the contents. Okay. So MIME extension to the RFC 5322 framework intended to address the problems of the use of SMTP. What were the problems in SMTP? To address that, we have a protocol called as MIME. So what were the problems in SMTP? What were the limitations in SMTP? Cannot transmit executable files or other binary objects or text data with native language characters. Is that clear? Original SMTP, the normal SMTP cannot do this. Cannot transmit an executable file or other binary objects or text data with native language characters. Suppose if you write a text data with your native language, SMTP wouldn't support it. But due to MIME, it is supporting it. It's an extension. MIME is an extension for SMTP. Servers may reject mail messages over a certain size. Yes, as I said you, MIME, if you have a MIME extension, there is no limitation for the text that you write. Is that clear? Cannot handle non-textual data. Yes, if there are any attachments, SMTP cannot handle it, but MIME will support that. MIME is intended to resolve these problems in a manner that is compatible with existing RFC 5322 implementations. Okay, MIME is intended to resolve these problems in a manner that is compatible with existing RFC 5322 implementations. So some history about the mails. When email was first developed, people could only send plain text messages. MIME was developed in early 90s to allow people to send pictures, sounds, programs, and general attachments. MIME specifications include the following elements. Uh, so MIME, 5 new message header fields. Yes, very important. 5 new message header fields in MIME provide information about the body of the message, content format, transfer encoding, message header fields, MIME version, content type, content transfer encoding, content ID, content description. All these are the new headers introduced to SMTP with the help of MIME. Is that clear? Because MIME is just a extension. Now, MIME content type. So, type if it is a text, multi-part, message, image, video, audio, application. So description about it is given here, so you can go through this sometime. I'm not going to study this now or read this now. Whenever you are free, you can go through this because it is not quite important, but have this information with you. Okay. MIME transfer encodings. Basically, this also uses base 64. You can see there are 7-bit encoding, 8-bit binary, quoted printable, base 64. This is radix 64 actually, students. So this is about the actual MIME. And what is SMIME? The next thing is a secure version of MIME. Okay. So these things are not required. I will anyway remove this when I send the PPT to you. Yeah. MIME has no security features, can be read along its route or forged. Is that clear? If you use only MIME, it doesn't have any security features. For that, you have SMIME, which provides security. SMIME is a secure version of MIME. Security enhancement to MIME email. MIME provides supports for varying content types and multiple part messages or multi-part messages. with encoding of binary data to textual form. SMIME added security enhancements for this. Is that clear? Have SMIME support in various modern mail agents? Yes, MS Outlook, Netscape, etc. All these are supported with SMIME. So what does SMIME gives us? Four things you have to keep in mind: security, authentication, integrity, non-repudiation. All these things are the uh, characteristics of MIME. So security, we all know what it is. Authentication, also again we know completely what is authentication. What is integrity, we know that. And finally, SMIME puts all these techniques together to create a practical, efficient, reasonable, secure email protocol. So symmetric cipher, we will see this where we are going to use it. It uses symmetric ciphers. That means session keys. It uses public keys. I mean the public and private key pair it uses. And if it is using a session key, it is triple DES. If it is public key, it is RSA. And for hashing, it will use MD5 or SHA. So SMIME for secrecy only. For example, let us consider Chunk and Katie are communicating parties. So basically, again, we don't need this actually, because it is just a scenario which is taken here. So as I told you, SMIME is extended version of MIME, and MIME is an extension for general SMTP, and PGP is a totally separate thing. So we have seen that the same thing, whatever the support that you received in PGP, the same support is there in SMIME also, but even for the attachments. Is that clear? And there is no limit in the message that you need to send. Is that clear? So for authentication, message is authenticated just shown as above. Okay, here. So another diagram I will share students regarding SMIME. So I will add it in the slide and I will send it to you. Okay. So that's about SMIME. So do you have any questions, students, regarding SMIME? One more thing you have to keep in mind, SMIME provides security even if you are using your mail server from the mobile devices, or it also supports for wireless technologies also. For the mobile devices, SMIME gives security. Is that clear?
Yes, sir.
Any? Okay. So any questions regarding this, students? Phishing attacks, we will see. We have a separate topic where we will discuss about different types of attacks. So what is it? I will discuss with you. So SQL injection attacks, I am not going to discuss these attacks now. Is that clear? So because yeah, these attacks we will discuss by end of your course. Different types of attacks, to which kind of communication these attacks are more effective, how to control it, those things we will see later. So I hope PGP and SMIME is clear to you, students. Do you have any questions regarding PGP and SMIME? Only Radix 64 I have to discuss. I can't start it today because we have less time. Or do one thing. Yes, make a note of this, students. Make a note of, take the heading as Radix 64 conversion. Radix 64 conversion. See, for every character, there will be a 6-bit value. Is that clear? For every character, there will be a 6-bit value, and that will be converted into ASCII. Is that clear? Zeros and ones, it will be converted, and that will be sent in the medium. Okay. Now, that will be converted into binary. Okay, not ASCII. That will be converted into binary, and that will be sent. So character encoding, say for capital A, it is 0. Please make a note of this, students. For capital A, it is 0 and it goes on, it increases. For B, it is 1. For C, it is 2. All these are capital, and finally for Z, it will be 25. Is that clear, students? From capital A to Z, it is 0 to 25. That is the 6-bit value with respect to radix 64 conversion. Capital A to Z, it is 0 to 25. And for small a to Z, it will be from 26 to 51. Please make a note of it. It is from 26 to 51. Okay. From capital A to capital Z, it is 0 to 25, and small a to small z, it is 26 to 51. And next starts numbers. If the character encoding is 0, for 0 it is 52, and for 9 it is 61. For 0 it is 62, and for 9 it is 61. For 9 it is 61. So totally from 0 to 61 we know now. 0 to 25 it is capital A to Z. 26 to 51 it is small a to Z, and from 52 to 61 it is 0 to 9. Now down 62 is plus symbol. Is that character encoding? 62 is plus symbol, and finally 63. Finally 63, in short you can call it as pad or padding bit. So basically it is the encoding is backslash r equal to for 63. So that is totally 64 from 0 to 64. That's why it is called as radix 64 encoding. And in some cases this encoding may not be sufficient because you may have any other characters apart from this. But nowadays, even radix 64 is also not used. Many other encoding techniques, bigger encoding techniques have come in the technology, and that is being used. But this is there in your syllabus with respect to SMIME, we have to study it. Radix 64 means there are 64 different 6-bit values, and that values is corresponding to a particular character. Is that clear? So as I said you, from 0 to 64, it from 0 to 25, it is capital A to Z. From 26 to 51 it is small a to small z, and from 52 to 61 it is 0 to 9, and then 62 is plus, 63 we call it as pad, that is either backslash or equal to. Now how do you convert it? Okay, let me add a slide here. Okay. Okay, now if I have a data that has 8 capital K, small r, and capital M. What is the equivalent for 8, students? What is the radix 64 6-bit value for 8? Can anyone tell me? So the number ranges is from 52 to 61. If 61 is 9, what will be 8?
4 zeros and 1, and then 4 zeros, 3 zeros.
No,
0 0 0 0 1 0 0 0.
no. Tell me 6-bit value for 60. I mean,
So,
8. It is
yes,
60, right? For 80, corresponding radix 64 value is 60. When you convert 60 into binary, how do you write it? How do you convert 60 into binary? So 128 not required, 64 not required, 32. This is 32. 32 plus 16 is 48. 48 plus 8 is 56. 56 plus 4 is 60. Apart from that, you have 2, 1,
4 ones and then 0 0, sir.
Yes.
That
Am I right? 4
one.
ones and 2 zeros. What is the equivalent binary representation for 60 students? Can you tell that?
1 1 1 1 0 0.
Yeah, that's what I have written here. Clear, right? Now, what is the next character that we have here? Capital K. For capital K, radix 64 equivalence is 10. Is that clear? Why? Because capital A to capital Z, it is 0 to 25. So if you look for K, it is 10. Is that clear? I will share a diagram of that, the table with you later. So for capital A, it is 10. If it is 10, how do you represent 10, students? And you have to represent each value in 6 bits. Keep that in mind. In 6 bits. See, 8 we have represented in 6 bits. For K, it is 10. If it is 10, how do you represent 10?
0 0 1 0 1 0.
0, 0, 1, then 0,
0 0.
0. Because this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. 2 to the power 3 is 8. We need this 8. Whereas 16 we don't need, 32 also we don't need. 8 we need, and 4 we don't need because 8 plus 4 will become 12. But 2 we need because 8 plus 2 is 10, and this remains 0. Is that clear? So this is 8, this is K, 8. So why 8 we have written like that? 8's equivalent value in radix 64 is 60. This is 60. And K's equivalent value is 10. And now small r. See, for small letters in radix 64, it starts from 26 to 51. And for small r, it is 43. Okay, students, it is r is 43. How do you represent 43 in binary? We need 32. Yes, 6th bit is 32. We need 32 plus 16. What is 32 plus 16? It will cross 43. So I don't need 16. So 32 plus 8, I need it. Is that clear? 32 plus 8 is 40. I need it. So then I don't need 4 also, but I need 2. Is that clear? And then finally I need 1 also. Is that clear? So am I right? 1 0 1 0 1 1. This represents 43. Am I right?
Yes.
Okay. Then finally capital M you have. How do you represent capital M? What is the capital M value? It is 12. How do you represent 12? I don't need 32. I don't need 16 also, but I need 8. 8 plus 4 is 12. So I need 4 also. And other 2 is 0. This is 2 and 1. This is 0. So this is 12. Okay. So 8 is this, K is this, R is this, and M is this. So this is the binary representation of the radix 64 converted values. Okay. Now, is it clear, students?
Sir,
Yes.
that 8K RM denotes something, or you like receiver key or something, or like you have written randomly?
It is randomly I have written, that's all.
Okay, sir.
I can write my name also, Vishwas. I will ask you to convert it. So when you write that something in the mail, it will be converted in this format. This is the binary representation. Okay. But the other way also should happen. It is just 1 1 1 1 0 0 0 0 1 0 1 0 1 0 1 0 1 1 and 0 0 1 1 0 0. This is how data will go in the mail. But once the mail is received, the receiver should understand it and decrypt it. So how, what receiver will do? it's a continuous bits, right? So receiver will take first 6 bits, then receiver will take next 6 bits. Sorry, it should come till here, next 6 bits, then again receiver will take next 6 bits, and finally next 6 bits. So what is this value? This value is 60, this value is 10, this value is 43, this value is 12, and finally what is the equivalent representation for 60 in radix 64? For 60 it is 88, for 10 it is k, for 43 it is r, for 12 it is m. That is how the other way mapping will be done, and radix 64 conversion will happen like this. Is that clear, students? Am I
Yes.
clear to you? Okay. So let us see one or two more examples in the next class. This is about radix 64 conversion, students. So hope it is clear to you. We'll meet in the next class. Okay. So Monday we will have quiz. I will share you PPT, and Monday 4th hour will be your quiz. Portions for that is